My name is Eduardo Apolinario. I work on Union. I joined, I don't know, 5 weeks ago. And here today we're gonna talk about this feature that I added to the local execution workflow. Not to overload the term, but the ability to cache the result of tasks in local executions. So we all love Flight, but we know how complicated it is. And in the very first cycle of operations that you do, like you write your business logic, you test things locally, test remote, orchestrate, blah blah. Today we're gonna zoom in on just like one of the missing features that are missing from the local execution like pipeline, let's say. Task caching. What is this? It's this ability that Flight has had, like the remote version of Flight has had for, I don't know, ages now. Since I've seen Flight the very first time, like 4 years ago, this was already a feature. It's this ability to cache the output of a task, right? Few common use cases, like you're iterating on a workflow, you're like executing it multiple times. You don't want to spend time like waiting for the result of a test that you know is either potent or like it can be cached. Another common one is like you have this test that is shared across a huge number of workflows, or you're simply in the iteration phase, you're debugging a workflow, you want to cache a portion of it. You can with task caching. And how does it do this? This is like the prototypical way of caching a task in FlightKit. Notice the arguments cache and cache version to the task decorator. We're saying that this function called square is cacheable, and it has this particular version like 1.0, but it is an arbitrary string. Just put it 1.0 because the definition of square probably won't change in 1,000 years. But how does it do it? Remember, we're caching the output of a task, and the output can be like an arbitrary complex data type, like flight files, data classes. You pick. It's not restricted to like just primitives, so like scalar types. But it is a cache, so we have to think about like how are the cache keys of this bespoke cache determined. It really boils down to what mode of flight you're running, either remote or local. And as I said before, in this presentation, we're going to focus on the local, on the details around like the local execution. So if you're interested in how the remote case works, go check the docs. It's all described there. The criteria for creating or calculating the cache key in the case of the local cache or the local execution, we only take into account the cache version, which is that attribute that we saw in the previous slide, the task signature, inputs, outputs, the name of the task, and the actual inputs to the task. Like we don't want to cache the result of a task that takes like inputs A and B, where A is like an integer, B is another integer. But like if you pass like different inputs to this call, you don't want to cache the wrong thing, basically. So like the inputs are also part of the cache key. Local executions, we have to think this is very interesting feature that is not present in remote, which is like there is no clear way to invalidate caches or cache keys in remote flight. You have to resort to either change the version or modify the signature of your function. But in the local cache, in the case of the local cache, we actually provide you with another command in the PyFlight CLI that lets you clear the cache. So you run locally PyFlight local cache clear, bam, the cache is empty. Now I'm going to jump to do a quick demo of how this thing actually works. So bear with me because I'm not sure if Zoom will let me do this. You see, I can't see any of you, but please, can you see like two screens now, or just still like
Yes.
the Google Docs thing?
Yes, Eduardo.
Yeah, it's working.
It's working.
Yeah,
Great.
yeah. We see two. We see your two separate windows side by side.
Yeah, that's amazing. That's all I wanted to hear. Thanks, George. Let's go through this first demo. This is a very simple workflow. You know, doesn't do much. It basically calls this task called T1, which, as you can see here, it's set to be cached. It has a version called 0.1. Here, just like pretend that this is a very long computation, but here we're just like simulating that with a sleep of 2 seconds, and it just returns the sum of two integers. So how does this look like when you run locally? Let's see, first the cache just to be sure. Then let's run that workflow locally. You see that, you know, it is a very long computation, and it ran once. Now let's run the same workflow again, and it pretty much immediately just returns because, you know, things cache. You can see from the logs that we hit the cache for that particular, you know, execution. Let's go back to this again. It's just like, you know, calling WF1, passing A as 1 and B as 2. So let's change the version. Let's do like 0.2 now. Now it's no longer cached. You had to wait. There was no cache key. Let's just prove that the cache is working. The workflow immediately returns. Yeah, let's go to the second. So here, we are just sharing this task. I'm calling here expensive task shared between two workflows, between, like, you know, two workflows. So we have like workflow 1 and workflow 2, and what we're going to see is that in the case we execute, you know, workflow 1, and that takes, you know, 2 seconds. It returns like 3. And when workflow 2 is about to execute, it pretty much returns immediately because we're hitting the cache. So it's once again, oops. So this is a little quick, but here's the execution of workflow 1, and when workflow 2 runs, we see a cache hit for those two inputs, A1 and B2. Similarly to the other case, if we change the version, change the signature, it will all, you know, invalidate the cache. Now for the final example. So as I said before, the output of tasks or inputs can be arbitrary data types. Like we cache any value that can be serialized by flag, right? So in this particular case, we have a very simple workflow, excuse me, that it creates a flag file, writes some string to it, and returns it, right? In the test, like the actual workflow, like it runs, and we just check that, hey, this thing actually returned the string that we wrote, like to the flag file, right? Again, I'm pretending here that there's a long and expensive computation happening, but just to prove that the cache actually can load the flag file that we returned from this task. So let's run this. I think I have this running. And it's return here. -03. Now we're reading 3 seconds. But, you know, thing ran. It did not fail. Like, remember, the workflow actually doesn't assert. So if we could not run or load the the string hello world, a new line, this thing would have failed miserably. Now, run this again. It pretty much returns immediately because we hit the cache. You actually see a cache hit. And I don't want to take a lot of time, but let's dive quickly into like how the actual local cache does this. So we use this cache as the backing store for the cache. But if you pop the hood of this cache, how it does it, it's pretty simple. It's just like a SQLite database, and here we're just showing the contents, like the two tables that the cache uses to like as the backing store, right? So then just showing, hey, I have a table called cache and a table called settings. The cache table is the interesting one. So how does it look like? Here's a schema of the cache table. It's pretty simple. It has row ID, the actual cache key, like the raw value that you try to store, and so that's not super interesting. And here, as like the very last column, you have the value, right? So how about we do a little inspection just for fun, just to see what is happening under the covers. So in this case, we're just clearing the cache and running workflow number 1 that we run earlier today, and that thing takes like 2 seconds to run. Here the result written to the standard output. Let's take a look at the cache. Just doing a select star from cache, and here's what it looks like. As row ID 1, here's the cache key, so it's the name of the package, the name of the task that was which is part of the cache key, and the inputs, right? The rest is not super important. Yeah, I'm just showing if we wanted to like see the contents of the cache in a more friendly format. It's just like outputting it in JSON. We can see row ID, the actual cache key here. This is a very long thing in the value. And just for kicks, let's run all 3 workflows that we have and check the values of the cache. This should run okay. Here's the contents of the cache. We have like 3 values. So row ID 1, row ID 2, row ID 3. This is like the 3 tasks that we defined in each one of those workflows. Yeah, this is more a curiosity. Again, word of caution: do not rely on this. Like, we currently use this cache as our backing store, but like there's no guarantee that 5 versions from now we will not change this. All the interactions with the cache should be through pyflight local cache command, which right now we only offer one subcommand that lets you empty the cache. But if the community thinks that it might be useful to provide ways to inspect the cache in a more friendly manner, this is like the extension point that we provide.